The topic we're exploring today is how healthy buildings and IAQ monitoring can help in the fight against COVID-19. Our focus will be around how to leverage continuous monitoring and also the Reset Air Standard. To start off, I would like to first invite our wonderful panelists to introduce themselves. Each one of our panelists brings a different perspective on continuous monitoring and performance monitoring, from hardware, software to implementation. First, we have Liam Bates of Kaiterra. Would you like to do a quick introduction of yourself?
Sure. So thanks, Stanton, and good to virtually see everybody. So my name's Liam. I'm the co-founder and CEO of Kaiterra. We are creating low carbon, basically helping buildings become low carbon and healthier. So we offer hardware-enabled solutions to help people understand what's going on in their environment and ultimately improve it. So the foundation of that is good data, and I'm excited to be here to talk about that today.
Thank you very much, Liam. Next, we have Maggie Sullivan of Switch Automation.
Hi, everybody. My name is Maggie Sullivan. I'm a digital building engineer at Switch Automation, and I am a Reset accredited professional. So nice to meet you all, and looking forward to talking more.
Thank you very much, Maggie. And lastly, we have Peter Rake of Switch Automation.
Yeah, thank you. Thanks, Stanton. Yeah, Peter Rake. I'm the Chief of Product here at Switch Automation. And Switch Automation is a data platform for the built environment, particularly commercial buildings. And we're similar to everyone, I think, that's on the call, is about decarbonising the built environment and doing that with data. So data-driven insights is what we're all about.
Excellent. Thank you very much. So we're going to jump right into it. But before we start the discussion, let me provide a quick overview of the Reset Air Standard, because that's part of what we'll be targeting and focusing on today. The standard is a data quality standard and assessment tool focused on performance that helps the built environment standardize continuous monitoring requirements for IAQ and other, mainly for IAQ. But with continuous monitoring, building owners and operators are able to access data in real time and leverage the data to implement targeted and cost-efficient solutions quickly. Because the standard is focused on performance and continuous monitoring, the collection of data and the quality of the data is of utmost importance. So Liam, can you tell us more about the importance of data quality and why it has become a challenge for the industry?
Yeah, this is my favorite topic. It's something I feel very passionately about. So, and just now Peter mentioned the importance of making data-driven decisions when you're trying to solve a problem. Especially here, 21st century, really all of our decisions should be based upon data. And the foundation of that is having good data. So yeah, if you want to make a good decision, you have to start with good data. That is, there's no way around that. And I think one of the major challenges with IAQ is that it can be very hard to tell, as a sort of a normal human being, if data is reliable or not. With temperature or humidity, we essentially we're all sensors. If somebody tells you that it is 30 degrees Celsius in the room and you are freezing, you know that there's a problem, and the sensor that told you it was 30 degrees Celsius is clearly incorrect. So we can do that with temperature. We can do that with humidity. If you're sweating and somebody tells you there's a sensor that says that it's 5% relative humidity, you know that the sensor's broken. But we can't do that with air. Air is invisible. There's no immediate way to tell if the CO2 levels are 400 ppm or 6,000 ppm. Same thing with particulate matter, unless it's really insane levels, and many other parameters. So one of the challenges is that you can have basically sensors are black boxes, and you just have to trust the data that's coming out. It's very hard to make that sort of human gut check just by looking at the data and seeing whether or not it lines up with how you feel. And that's a problem, because the impacts of these parameters that are found within indoor air quality are really, really important. CO2 has a massive impact on how we feel right now in the moment, has a massive impact on our productivity. Particulate matter has a massive impact on our short-term comfort, productivity, but also our long-term health, really serious long-term health effects. So it is paramount that we measure these things, and the trouble is that it can be hard to trust the devices that are giving us that data. And that is, of course, why reset is so important here, because there needs to be a third-party standard that you can rely on to say, okay, this sensor that says it is accurate to, for example, plus minus 10%, has been verified to actually tick those boxes. It's been verified to collect all the data that is actually needed to allow us to make intelligent decisions, and it's been verified to be accurate. And basically, it does what it says it does. And the unfortunate reality is that there are a lot of products around the world that maybe don't necessarily do what they say. That you can find online, or if you go on eBay, there's a million different options out there, and a lot of them unfortunately don't do what they say. And again, so that's I think really why this is important, and why Reset's role in this is also really important.
Thank you very much, Liam. Yeah, so with data, we obviously start from the hardware perspective. Kaiterra has Reset accredited hardware, high quality hardware that can collect data that is accurate. And with COVID-19, what's happening is that there's a lot more talk about indoor air quality, because COVID-19 is transmitted through the air. But the solutions that have been suggested by a lot of entities is to bring in a lot of fresh air with no kind of consideration for the data or what the actual space is, whether the space is actually being occupied. So Maggie, as a digital building engineer who is constantly helping buildings optimize their operational efficiency, how does Reset Air and continuous monitoring potentially add value to the smart building ecosystem?
Yeah, so as Liam was just saying, it can be really challenging to obtain clean and credible data. I think the verified and quality data that comes out of a Reset accredited building really gives people the peace of mind that their workplace is supporting their health and wellness. So there's a tremendous amount of value that comes out of giving people that, and making people comfortable to return back to the office. On the other hand, as you were saying, the more stringent fresh air requirements that support this can end up using more energy if it's not done right. So the continuous monitoring that is provided by Reset can support more dynamic control strategies, such as demand-based ventilation. So with demand-based ventilation, we can overventilate when it's most important, but then we can maybe not ventilate as much when a space is unoccupied. And this really ends up reducing wasted energy. I think this has grown especially important during the pandemic, since we've seen occupancy patterns become much more unpredictable. They've changed a lot, and I think we need dynamic strategies to really begin to account for this. Yeah, we've seen buildings kind of sitting around largely empty, wasting lots of energy. And then when everybody decides they want to come in, it's kind of contributing to sickness and not wellness. So ultimately, the true value add that Reset enables is the ability to holistically weight these two equally important goals of occupancy wellness and energy efficiency, so that we can meet the needs of the occupant without compromising green building standards. And we're able to really take changing conditions into account, because a building is not a static thing, and people change their habits. So yeah, I think that's really the value add. I'll pass it back to you, Stanton.
Thank you very much, Maggie. So Reset Air is an entire ecosystem, and it focuses on the data collection aspect of it, from the journey from data collection from hardware to collecting it and aggregating it on a data provider platform, software platform, and then having it visualized on a digital interface. How might owners, building owners, and Liam, how might building owners and operators leverage this data for actionable insights?
Yeah, absolutely. And if you'll give me a moment, I'll just share a share my screen quickly. I think Peter will be able to talk. Really, I think there's two parts to the equation, right? There's making sure that the data is, like we talked about, accurate, that everything that needs to be collected is being collected. And then the second part of that is really taking that, bringing in other inputs. And I'm sure Peter will talk a lot more about sort of that side of the equation, the visualization side. So just to check, can you guys see this presentation?
Yep.
Perfect. Okay. So yeah, I'll just focus quickly on sort of the first half of that equation, which is making sure that data is collected, the right things are being measured, and that they're being handled in the right way. This is just a kind of quick intro to the types of projects that we work on. Very proud to have worked on a lot of great reset projects. So we do a lot of different things, from commercial buildings to retail, etc. And behind all of that is the physical sensors. And when we've designed the sensors, we've actually built them very strongly around the reset guidelines. What is required for a sensor to be accredited, because we think that that is a very good list of sort of the boxes that need to be ticked in order for a product to provide the data that is necessary for all of the future steps. And a lot of that shows, I think, in some of the features of the actual physical product. So number one is, of course, you have to have best-in-class sensors and algorithms to allow those sensors to function in an optimal way. So without getting too into the weeds here, in order for a product to provide accurate data, it needs to have accurate hardware, so just physical sensing components, and then you also need to have the right level of accuracy and precision and the right algorithms to really get the most out of those physical components. There's also a modular design, which I'll talk about briefly in a moment. And of course, anything which is an IoT product, IoT is sort of a double-edged sword, right? It opens so many possibilities, because we can take the data and really get it off of the device and get it into the cloud so that it can be processed, so that it can be viewed by different parties. The data can be sliced in different ways, analyzed. But of course, these are internet-connected devices within a physical building. So in order to really be able to make the most use of that data, it's super important that it is secure, accessible, and of course, quality control is a really important piece of all this. So here are a couple of our reset certified products, one with a screen, the SenseEdge, then the SenseEdge Mini, which is very discreet without a screen, blends into the background. You don't know it's there, but it's helping you collect all sorts of air quality readings. And then, of course, a dashboard to help visualize the data. And when we look at what parameters we should be measuring and monitoring, it is, again, sort of defined really following the reset standards. So all of these are parameters that are required by reset, and also can be used in calculations of viral transmission index, for example, to understand what is the risk of virus transmission, etc. And finally, I think this is one of the most interesting and most important things, which is that we've really designed all of our products so that sensors within them are separate from the monitor itself. So sensors can be removed, can be replaced, and there are two really big benefits. One is that it makes it incredibly easy and smooth to recalibrate a device. Devices need to be recalibrated over time. It's very important if you want to ensure their accuracy, and you want to ensure good data, which is sort of the foundation of everything else. So being able to remove and swap out sensors is really, really helpful to making sure that the device, 10 years after it's been installed, performs just like it did on day one. Also, sensor modules can be upgraded over time if there's a need to measure other pollutants, or if there's new technology that becomes available. For example, we've recently released ozone modules. Seen a lot of, throughout the pandemic, people have installed a lot of various ionization technologies, and sometimes with that there are concerns about ozone generation, for example. And so by simply releasing a new module, it has made it possible for users to upgrade all of their existing devices without having to rip the thing off the wall, try to find a new provider, try to integrate this new hardware device into switch automation, for example, et cetera, et cetera. So this is really important, and ultimately saves the customer, the end user, a lot of money, because it is much easier, much faster, and much cheaper to recalibrate a sensor by swapping out a module than by pulling it off the walls, shipping it back to the manufacturer, and getting it back 2 months later. So that's kind of, I think, the first half of the equation. And the second half, of course, is more on the analytics side, which I'm sure Peter can walk us through.
So thank you very much, Liam, for introducing the hardware side of things. And then now I do want to invite Peter to talk about, after taking this data, what can you do with it on the software side of things?
Absolutely. Thanks, Stanton. And a great introduction there, Liam. Thanks. So like, I think everyone gets the gist from the theme here of the webinar. Oops, sorry. So yeah, so Switch Automation is a data collection platform, and we're able to take data, and we're hardware agnostic, but we can normalize all the data. So with products like Kaiterra, where they have a rich and published integration path using their API, we're able to get the data in from there efficiently. And to Liam's point, calibration is really important, and the quality of data is really important. So we can also, with our own algorithms and fault detection, we can identify and send notifications from that. So what I'm going to share with you is just a few visualizations that have been anonymized, but these are being delivered into our clients. So as a Reset accredited data platform, we're also able to send the data using the Reset published APIs from the certified hardware right through to then being certified in the Reset platform. So this is an example of where we've overlaid Kaiterra sensor information into charts and trending, but also overlaid that onto three-dimensional floor plans, which are obviously an intuitive way of identifying where you might have some hotspots on good or bad air quality areas, and then we can itemize by office or by zone if it was, so we can have all of that. So this enables people to have this interactive dashboard that's essentially a report, and it's all in real time. So this is where the real advantages are of connecting to physical hardware, IoT being quite broad, but introducing any of those sensors. So this could be combinations, and these dashboards could be a blend of building management system data. So being that integration sort of middleware platform, Switch is able to deliver all sorts of data that might show and be able to help you. Like Maggie mentioned earlier, these buildings are sort of living and breathing. So as much data as we can present in this intuitive environment, you'll be able to then have better outcomes for all of your occupants. Appreciating that this topic is actually fairly technical, so we also do report style dashboards where we can sort of talk about the programs that are running in the building. So like where CO2 levels, a lot of people don't necessarily know whether 400 or 1,000 is a good parts per million. So we're able to present these in reports as a dashboard. So, excuse me, hang on. Apologies for that. But then we can also introduce controls. So Maggie touched on before, where we can do like dynamic control strategies if we're connected into systems that are able to affect the environment in real time. So if you think about getting building management system information in, indoor air quality, as we've discussed on this topic, you can actually introduce this. So these three visualizations that I've shared with you today has gone from a sort of a floor plan, my environment or my tenancy particularly could be in a building, through to reporting out to higher stakeholders that may not be interested so much in the technical, but when you're starting to think about reoccupancy of buildings, understanding in sort of natural language what's going on in my building, and am I walking into a safe environment. from an air quality standpoint. And then the final one was really about, potentially command and control of those environments. If the outdoor air quality is fine, then maybe we open up outside air dampers to bring more through and flush the building out. So that's how Switch really brings in these sensors, normalizing the data from the sensor inputs and establishing those integration paths from the edge devices.
Excellent. Thank you very much, Peter. So from what I'm hearing, it sounds like that the hardware and the software layers, collection of data, and then having it on a platform essentially helps you establish the precursor for any kind of automation that you want to do. And automation, smart buildings is going to be key, very much key to maintaining healthy building spaces while maintaining the lowest carbon footprint. So we're going to come to the last part of this webinar, and it's looking at how you might implement. Getting started with reset and air quality monitoring is simple, and it's relatively low commitment because with the reset standard, the focus is on the collection of data and measuring of air quality, and doesn't target specific requirements on solutions. So the best way to get started is typically to reach out to an accredited professional who can help take care of the implementation of projects. And Maggie, as a recent AP yourself, can you share what the steps are for a space or a project if they want to achieve Reset Air accreditation?
Definitely, Stanton. So I think we're about to get a pop-up on the screen that kind of goes through those first 6 steps. But yeah, I mean, the first step is really finding somebody that can help you assess what you have and figuring out what kind of project strategy makes the most sense for you. Whether you're going for a core and shell or an interior certification, there's a lot of very straightforward kind of rules that help you determine what the optimal sensor placement is. And all of this guidance very much takes into account how the space is actually used, and it helps you to define what the locations that will gather the best data for your space, and then finding a network solution and setup that works for you, installation and maintenance, and then connecting to a cloud provider. Ultimately, like, this process is pretty straightforward and really lets you get to a point where you're able to start gathering data and really figuring out what situation you're facing in your building. And that's really one of the biggest benefits of Reset, as you mentioned. So yeah.
Excellent. Thank you, Maggie. So I think that's all we have right now for the base content of the webinar. We're going to go into Q&A, and we have our first question from Daniel. Beyond temperature and traditional temperature, humidity, and carbon dioxide, CO2, how is VOC and PM 2.5 or 10 being practically used to improve air quality? So I think I'll start with Liam for this question. Do you have any thoughts on this?
Sure. So it's very easy to go deep into the weeds here, so I will do my best not to. So I think a simple way to look at it, VOCs are often quite similar to CO2, and so in terms of the way in which you'd approach it, CO2 is being generated by people in the space that are breathing, and VOCs sometimes can be this very similar sources. Sometimes it can be furniture or paint. But it's fixed in the same way, which is dilution, bringing in outside air. And so simply, I guess a fundamental way to look at it is if we're doing it for CO2, why aren't we doing it for VOCs? Because the same sort of impact on health and productivity has been shown, and we know how to fix the problem. So simply measuring it and then taking those next steps is something that we should be doing. PM 2.5 can be a little bit more complicated. And I think that's really where there's a lot of value generated by the analytics on this kind of data. I mean, is this coming from outdoors or is it coming from indoors? once you know that, then you can start making more intelligent decisions about whether you should be increasing outside ventilation or decreasing it, or maybe fundamentally you need to have a different grade of filter in your air handling unit. And so these are some of the takeaways that you can get from this data, and then based upon those you can make very clear decisions about what you should do to improve the environment. And ultimately you can reduce your PM 2.5 levels, which is a really great thing.
Thank you very much, Liam. Maggie, do you have anything you might want to add to this?
Yeah, I think the variety of sensors, as Liam was touching on there, that Reset supports, and the clear kind of guidelines that Reset gives you helps you determine what is a healthy place based off of those different parameters. I mean, I believe that all of those parameters are included in the Reset standards. So,
got it. Wait 1 second before you go on. I want to ask one more question. So, if a building does not already have a smart building platform and they want to implement Reset, how much time approximately does it take for a project to implement everything, the sensors and the platform, etc.? Maggie, this is for you.
Yeah, I mean, I think it can be a relatively straightforward process. I don't have a great estimate. Maybe Peter can chime in here, but I mean, the hardest part is pretty much like ordering the sensors and waiting for them to come. The whole process of kind of determining your strategy of what you have is relatively short, and it's pretty easy to just get to the point where you have data flowing and you can start actually trying to improve your environment. So I don't know, Peter, if you have any input on the kind of like time to value there, but
I would second that. It's kind of just do something, and even if it is just to order some sensors, reach out to Liam and get a box shipped to your office. And if it's then going to be plugged into Reset, like we said, we've already got the middleware driver that's going to take the data from the Kaiterra API. We'll feed it through when we put it through our Reset driver that then sends it through to Stanton and the team. So really, it's very efficient. We're normalizing the sensor information on the way through anyway, and so I really think that the best step is to actually do something. But it isn't very long, Stanton. To ultimately answer your question, if you get a box of sensors and you can mount them in a wall in a day, we can have data commissioned in that same day. If we're talking about hundreds, yeah, we might be talking a few days. But we just did a building in our building that we occupy in Denver, and it was done in like 3 days, and we had data posting and we were validating it in the Reset platform, so straight in. So especially when Liam and your team have done a nice documented API, we got the data pretty efficiently.
Thank you very much, Maggie and Peter. I believe that time's up. So Saren, is that correct?
Yes, that's correct. Sorry. Thank you, Stanton and panelists, for sharing your insights.